Hello everybody, welcome back to our channel. In this video we're going to be working on a Physics 7B torque practice problem. As usual, if you're finding this content helpful, please make sure to leave a like and subscribe to our channel. So feel free to copy the problem on your notebook so that you can actually follow along. So the problem statement is that we have a 150 kilograms steel bar which is suspended by two ropes. The bar is 3 meters long and the ropes are attached, one at the right end of the bar and 1 meter from the left end of the bar. So the first question that we have to answer is, what are the magnitudes of the tension in each rope? So let's just go ahead and start with that. So as you can see, I have everything written down on my notes. I have the diagram copied here. I have the mass of the bar, the length of the bar, and then this child shows up on part B, so we're not going to look at that at the moment. So obviously this bar is suspended by the two ropes, so we're going to have some tension forces going up, and because this bar has a mass, then we will have a force by gravity right here. A force by gravity on bar. And how do we figure out this force? Well, we do have the mass of the bar, so this is just gonna be force by gravity is just mass bar times g. So this is just gonna be, I'm just gonna multiply by 10, so there we go. So this is 1500 newtons. Now we need to realize two things about this scenario. The first thing that we need to realize about this scenario is that the bar is not moving in space. And this means that the net force, that the sum of all of the forces acting on the bar is equal to 0. The next thing that we need to notice is that the bar is not rotating around any axis of rotation. So it's not really rotating. And this means that the sum of all of our torques on the bar has to be equal to 0. Now this is going to be very, very important because this is what's going to help us figure out what the two tension forces are. Now, the thing that makes students struggle the most with this particular problem is that we aren't really giving you guys any sort of rotation point. We don't give you any axis of rotation. And that is usually the hardest part to quote unquote figure out on this problem. So yeah, that's definitely the hardest part on these sort of problems, when you actually have to pick your axis of rotation, because that is exactly what you have to do. The bar is not rotating around any axis of rotation, and this is actually very useful because it basically means that we could pick whatever axis of rotation we want. Say we pick out this. So just think about it. What happens when you cut out this rope? Well, the rope is just going to start rotating around this axis of rotation, right? So this is one of the possible axes of rotation of this problem. What happens if you cut out this rope instead? Well, if you cut this rope, then the bar is going to start rotating around this bar, around this other rope, I'm sorry. So this is another natural axis of rotation from this problem. So we actually get to pick between these 2 points, and both of them are going to be suitable axis of rotation. So let's just see. So let's just go ahead and, I don't know, let's just pick this one. It really doesn't matter. So I'm going to pick this as my axis of rotation. Now, what does this mean? It means that I can balance out my torques, and they have to balance out to 0 since the bar is not really moving around this axis of rotation, right? So how many forces do I have in this problem? Well, I have 3 forces. I have this force that I'm going to call tension 1. I have this force that I'm going to call tension 2, and I have force by gravity. So let's just balance our torques. Using, this start point as our axis of rotation / pivot point. So because the bar is not moving around this axis of rotation, the net torque has to be equal to 0. Now, this bar is feeling a total of 3 forces, but only 2 forces are generating a torque around this axis of rotation, because the first tension force is being applied directly on the axis. So even though, yes, there is a force here due to the rope, this force is not generating a torque because R is equal to 0. So we only have 2 torques, the torque due to gravity and the torque due to tension number 2. And these have to add up to 0. Now, let's just go ahead and substitute this. So torque by gravity is just going to be R F grav. I'm not really gonna put an angle over here, because if you look at this R is just gonna be perpendicular to this. So I'm just not gonna put the sign, because it's gonna be sine of 90 all the way on this quiz. So I'm just gonna do RF. And then this other one is, the other R to gravity, R to the tension force, then T2, and then this has to be equal to 0. Now, let's just figure out our distances here. We do have a total length, so let's just go ahead and figure that out, and haven't figured that out already. So this is 1, and the entire thing is equal to 3. So if the entire thing is equal to 3, then this has to be 1.5, because it's exactly at the middle. So we have 3, and then it has to be exactly at the middle, and this is already 1. So this distance over here is just 3 minus 1.5 minus 1, 0.5. So the distance from the pivot point that we chose to this force by gravity is equal to 0.5. Now, the distance from our pivot point to the other tension force is just going to be equal to 1.5 plus 0.5. It's just going to be equal to 2. So let's just go ahead and substitute these numbers. Another thing that's going to be important here is that these 2 torques are acting on different directions. So this torque due by gravity, if you use your right hand rule, you'll see that it goes inside of the page. So this is going to go inside. And this torque right here, if you use your right hand rule, you'll see that it goes out of the page. So let's just put that as a little dot. Because we have 2 torques and they are going on different directions, we do need to symbolize that by making one of them negative. The usual convention is that into the page is negative, out of the page is positive. In the context of physics 7B at UC Davis, it really doesn't matter which one is positive and which one is negative, but I do recommend that whatever, whether you pick the convention or for whatever reason you decide that you want to do it the other way around, you do need to symbolize the fact that these 2 are going in different directions somehow. So you do need to make one of these negative, otherwise 2 positives are never going to add up to 0 anyways. So let's see. So I'm just going to go ahead and substitute the numbers. So this is 0.5, this is 1500, this R is 2, and then this is the force that I don't really know. I have to figure that out. So the tension force at 2 is equal to, I did say that so this is in, okay, there we go. So it's plus 0.5, 1500 divided by 2. So our tension force is going to be equal to 0.5, 1500 divided by 2, 375 newtons. And I got a positive answer, which makes sense because it's going up. So we're 375 newtons. Okay, so we already have one of the tension forces. If we can figure out the other one, then we're good. Now, there are two different ways actually in which we can figure out what tension 1 is. The first option is, well, if putting the axis of rotation here made it possible to find this force, what happens if I select this axis of rotation? Well, if you select this axis of rotation and do the exact same procedure, you're gonna see that instead of finding T2, you're gonna find T1. Exact same procedure, you're gonna get the other answer. The other thing, and that's totally fine, very valid. The other thing that you could use is the fact that the bar is not moving in space, which means that all of the forces acting on the bar have to add up. So up to this point, we have a force going down 1500 and a force going up of 375. And because this plus this plus this have to add up to 0, because the net force has to be 0, then we can use that to figure this out. So let's just go ahead and just write it. So this means that 375 minus, because it's going down, 1500 plus T1 is equal to 0. That means that T1 has to be equal to 1500 minus 375, 1125 newtons. And that's an easier way to figure this out, in my opinion. But again, if you just do the exact same procedure, things are gonna work out. So that basically solves the first part of the problem. So let's just go ahead and read the second part of the problem. So the second part of the problem says that a child decides to sit on the bar from part 8 right at the point where the rope on the left is attached. Okay, so I'm just gonna redraw this a little bit. So we have our left rope, the right rope, and now there's a child pushing this with 400 newtons. What are the new tensions in the ropes? Hint, if you're clever about choosing the pivot point, this problem is really quick. Okay, so basically our problem is going to be exactly the same up to this point. We do have T2, we have T1, the gravity is still acting on the bar, of course, 1500 newtons. So basically we added a fourth force, and given this force, of course, this is going to change the entire force distribution. But we have to figure out what is going to happen to T1 and T2. So we basically have to recalculate T1 and both of the tension forces. Now, why is this thing suggesting that we be clever about our pivot point? Well, this is actually very true. If we are clever about the pivot point, then this problem is actually very, very easy. Let me show you how. So remember how in the first part we selected the star as our pivot point, and we said, well, let's just balance out the torques using this pivot point, and we figured that out of the 3 forces, only 2 generate a torque because only 2 are not on the pivot point. Well, what happens if I decide to use the exact same pivot point here? The bar is still not moving, it's still balanced out, which means that the net torque is equal to 0. So that is still correct. But then how many of these 4 torques generate how many of these 4 forces are generating a torque? Well, when you think about it, only 2 of these 4 forces are generating a torque if this is my axis of rotation, because even though I added a new force, I decided to pick my axis of rotation such that the new force is being applied over here. So if I go ahead and redo this entire exercise, this entire, net is equal to 0, then I only have 2 torques. So torque by gravity and the torque due to this tension force. And then what's going to happen? Well, what's going to happen is I'm going to get this exact same result because nothing has really changed. I was clever about picking my pivot point, and I found out that T2 is still equal to 375 newtons. And I was able to skip a bunch of procedure just because I was clever about picking this pivot point instead of this pivot point. If I had chosen this pivot point, yes, I would have gotten an answer out of doing this. So it still works. It's not that it doesn't work, it's still gonna work. So feel free to try it out, but it would have taken us longer. And this is a quiz, arguably 20-minute quiz. So being clever about this, it's really, really helpful. Now, the only thing that we have to figure out is what is the first tension. Is the tension gonna be, given that T2 is exactly the same with or without the girl, the same? No, because the way in which we got this tension force was by saying that the net force is equal to 0, and we only had 3 forces at the time, which we balanced to figure out this one. Now that there is a fourth force, the forces should still balance out because nothing is moving. However, we do have an additional force, so we do need to rebalance our forces, so to speak. So let's just go ahead and do that. We have one force going up, one force going down, another force going down, and this needs, and T2 has, if I add all of these two, including T2, that has to be equal to 0. So I'm just gonna go ahead and solve for this. So the second tension force is gonna be equal to 1500 minus 400, plus 400, I'm sorry, minus 375. And there we go, that looks good. 25 newtons, going up. So there we go. Adding the girl on this problem basically only added a tension force over here, which means that if the girl is exactly over here, where this rope is going to be in charge of carrying the weight. This rope is not even going to feel the difference. The torques are still going to balance out. But yeah, so definitely an increase over here. But this is going to stay exactly the same. This rope is just not going to feel the girl. Oh, I just noticed that this should be 1 and this should be 2. But that doesn't really change our problem, does it? Okay, well, this basically finishes this quiz. I really hope that you found this helpful. If you have any questions, please leave them on the comments. And again, if you're enjoying this content, if you find it helpful, please leave a like. It helps this channel a lot. I'll see you guys in the next video. Bye bye.